Be learning about the absolute value parent function. So for this one, our parent function, we're going to have our x's as -3, -2, -1, 0, 1, 2, and 3, kind of like our quadratic. And the absolute value of all of our x's are just the positive value, so absolute value of -3 becomes +3, absolute value of -2 becomes +2, +1, and then 0, 1, 2, and 3. So absolute value just takes all of our values and turns them positive. So we're going to graph these. -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. So as you can see, our absolute value function is shaped like a V, and the arrows mean that it keeps on going. Because we know it keeps on going 4, 4, 5, 5, 6, 6, but we're just not going to plot all those points. So let's look at our domain. Our domain goes from the leftmost side, the arrow keeps on going, so this starts at -infinity, all the way to the right, again keeps on going, so positive infinity. You can either write -infinity to positive infinity, or you can just put the sign for all real numbers, because they mean the same thing. Now for our range, our bottommost point is this point right here. So our range starts at 0, bracket because it's a closed point, and then it keeps on going up forever, so it goes up to infinity, and that is our range. So some characteristics of this function: it is symmetric across the y-axis, which means it is an even function. We know that it is decreasing from -infinity to 0. So this entire section right here, doesn't matter which way the arrow is pointing, we always go left to right. This section is decreasing, and then it's increasing from 0 to infinity. So this part of it's increasing. And we have a minimum of 0 at x equals 0. Right, so our minimum is 0, 0. Okay, so let's take a look at how we're going to graph this parent function. So again, we're going to start off by writing the transformations. If we look at number 1, so this absolute value right here is what tells us that we are starting off with this parent function. So just like before, I'm going to start off by actually drawing little x's where my parent function is. So I have -3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. That's my parent function. And let's see what our transformations are. So we have this negative. This is a negative on the outside, so I know it's going to be changing the side of my y, which is an x-axis reflection. This +4 is inside, so I know it's actually going to be the inverse, so I'm subtracting 4 from my x's, which means I'm moving to the left 4. And the +5 is on the outside, so I'm adding 5 to my y's, which is really moving up 5. So these are the three things that are happening to my function. Which one am I going to do first? The reflection. So I'm going to start off by reflecting all these over the x-axis. So from the top, I'm going to reflect it over to the bottom. So 0, 0 stays there, but this is now going to be opening downward instead of upward. So these are all the points now. And these are the points that I'm now going to shift left 4 and up 5. So each point, I'm going to move left 4, 1, 2, 3, 4, up 5, 1, 2, 3, 4, 5, left 4, up 5, left 4, 1, 2, 3, 4, up 5, 2, 3, 4, 5, left 4, up 5. As you can see, it's going to be the same shape as this, so it should be a V. Connect them, draw an arrow because it keeps on going. And this is my function. So this should look just like these points right here. They're all separated by 1 over 1 down. This is my function, so my domain is left to right, goes on forever in both directions, so I'm just going to put all real numbers. My range, so notice how it's pointing down, so the lowest point is going to be negative infinity, and then the highest point is going to be a y value of 5, because the smaller number goes before the bigger one, and again, range is y, so be careful you're using the y value. Okay, let's take a look at number 2 now. So for number 2, there's something we have to do before we can write down our transformations. So remember what I said, when you have two different transformations happening inside of your function, it has to be separated by a parentheses. So right now you don't have a parentheses there, so you need to factor a 2 out. So right now it's 2x minus 6. I want to divide both of these by 2, so it turns into 2x minus 3. Because I need to have that parentheses there to separate the two. And then this is what I'm going to use to describe my transformations. Okay, so let's first look at that 2. We know the 2 is affecting your x, but if it's affecting your x, it's the inverse. So we're actually multiplying our x's by 1/2. So this is a horizontal compression because we're multiplying by 1/2. And then the minus 3, again, inverse, we're really adding 3, which means we're moving right 3. So because it's our absolute value, we're again going to start at the same parent function. So same V shape. The first thing we're going to do is compress horizontally. So we multiply before we add or subtract. So we're multiplying all of our x's by 1/2. So we're taking all of our x's and we're squishing them in this way. So it should be a skinnier V now. So this right here, this one way on the outside, this is a 3. If I half 3, it's now going to be at about 1.5. So in the middle right there. This one's at 2. Half of it's going to be at 1. Half of this one's going to be at 1/2. 0 stays the same. And then the other side's going to be the same. So 1/2, 1, and then 1.5. So see how it's now a super skinny little v. And we're going to now just move all these points 3 to the right. So this one goes 1, 2, 3. 1, 2, 3. This one actually ends up on top of it. 1, 2, 3. And you end up with a function that looks like this. So it's been moved 3 to the right. So my domain is all real numbers. My range is starting at this point right here, which again, look at your y's. Be careful you're not looking at the x-axis. So it starts at 0, goes up to infinity. That's number 2. Okay, let's look at number 3. So again, just like the one we just did, we need to have a parentheses separating this 1/2 from the negative 2. So we're going to factor this 1/2 out. When you divide 2 by 1/2, it's really the same thing as multiplying by 2. So this gives you x minus 4. Because think about if you were to distribute it back out to this, 1/2 of 4 gives you 2. So this is now going to be a 4. So now let's write our transformations. This negative is on the outside. It's affecting our y. X-axis reflection. The 1/2 is affecting our x because it's inside the absolute value, so it's the inverse, so it's going to be a 2 times x. So it's a horizontal stretch by 2. And then the inverse of x minus 4 is x plus 4, so we're moving to the right 4. So again, we want to start off with the same parent function. And now we want to start off with our reflections. We're going to reflect across the x-axis. So now it's going to be going down instead of up. And we are going to multiply all of our x's by 2. So we're going to be stretching it horizontally. So now we're going to make it wider because we're pulling it out. So each of my x's, so 0 still stays 0. This right here is 1. We want to stretch it out to 2. It's at, this one's at negative 2. We want to make a negative 4. Negative 3, we want to make a negative 6. So see how they've all been stretched out. Same thing on this side. It was 1, now it's 2. Was 2, now it's 4. Was 3, now it's 6. We're multiplying everything by 2. So this is what I'm going to take and now shift to the right 4. So each of these points I'm going to shift to the right 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And it should retain the same shape that it was before. So it'll still be wider than our parent function. Okay, so our domain is again all real numbers, left to right, goes on forever. Our range in this case is pointing down, so negative infinity, and it stops at, this is my topmost point, which again, be careful, your y value here is 0. It's not 4, 4 is your x. So negative infinity to 0. Okay, last one we're going to graph. So this one, already separated by parentheses, so we're good. Let's just describe our transformations. We have 4 on the outside, so 4y. The vertical stretch by 4. The 1/3 is on the inside, so it affects your x. It's inverse, so it becomes 3x, which is a horizontal stretch by 3. X minus 6 is on the inside, so we're really moving to the right 6. Minus 5 is on the outside, so we're moving down 5. Okay, so again, we're going to start off at our parent function. And so if this is our parent function, we're going to first do our stretch. So this one's a little complicated. We want to multiply our x's by 3 and our y's by 4. So before, if it was, so 0, 0 still stays 0, 0. But before, it was 1, 1. When I multiply 1, 1, 3 times x, 4 times y, 2, 2. This is going to become 0, 0, 3, 6. And then my y's are going to become 4 and 8. So I'm multiplying all my x's by 3, all my y's by 4. So these are the points that I'm going to be plotting. So 3 over 4 up, and then 6 over 8 up. And the next one's going to be off the graph, so I'm not going to worry about it. So 3 to the left, 4 up, 6 to the left, 8 up. So these are the points now after I've done my stretches. And I'm going to move each of these points right 6 and down 5. 2, 3, 4, 5, 6, down 5, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And this one's going to go off my graph as well. So this is what this one looks like. And my domain is all real numbers from the left to the right, goes on forever. My range in this case starts right here, which is a y value of -5. And it's going to go on until infinity because it points up.